In this section, I'm going to talk about the third law of mastery. The third law of mastery argues for teaching like a doctor. This turns the usual order on its head a bit. So instead of teaching first, it's arguing for teaching last. First, the teacher assesses the student to diagnose any problems and then adapts their teaching to treat these problems before introducing new concepts. Why is this approach so important? Well, imagine what would happen if a consultant walked into an intensive care unit of 30 patients. He took a quick look around and prescribed them all the same treatment, no matter what their condition. How would that turn out? Doctors design individual treatment because each patient is different, and each patient reacts differently to the treatment they're given. What about students? Do they all react in the same way to lesson material? There's a children's story that helps us answer this question. In Fish is Fish, Fish is very curious about the world outside his bowl. Frog, his friend, comes back with exciting tales from the land. I have been about the world, hopping here and there, and I've seen extraordinary things. Like what? Asked the fish. People. They walk upright, and they wear clothes. What do you think the fish thought people actually looked like? This story highlights one of the most important factors in learning. Students interpret information in terms of what they already understand. So what we already know determines what we learn. If the students, like the fish, don't have the right foundational knowledge, or have knowledge that conflicts with the new ideas you're introducing, they won't be able to make sense of it. There are two important consequences for teaching. Firstly, we can't transmit a new concept directly. We can only help them in the job of constructing their own understanding. Secondly, we need to know what knowledge students bring with them, so that we know how to help them build on it. What do students already understand about science? Well, you'd be surprised. Even young infants have an understanding both about the natural world and how science works. The image here shows an example. The diagram shows a table with a box on it. A gloved hand reaches out from the window and puts another box either on top of the box or beyond it. Infants express their surprise by looking long at the box in mid-air, suggesting they possess an expectation regarding what is and what is not physically possible. Similarly, infants also understand that objects are displaced when they bump into moving objects, and objects at rest must be propelled into motion. So even a 3 to 4 month old infant already has an understanding about physics, that objects need support to prevent them falling to the ground. Now, these understandings can be resources that will help students grasp new ideas. But some of the science students have learnt before school can act as obstacles to further learning. In a classic series of videos from the 1980s, researchers asked Harvard science graduates to explain why the seasons happen. Almost all of them, including one professor, replied that it was because the Earth got closer to the sun in summer and further away in winter. Now, we know this is wrong, but why? Well, the reason is they had a faulty model of the Earth's orbit and thought of it as a highly elongated ellipse instead of it being nearly circular, with the Earth's tilt causing the seasons, not the distance from the sun. You can see how common textbook diagrams might have inadvertently contributed to this faulty model. Having faulty models is a problem. First, many concepts are hierarchical, building on simpler ones, so you can't really grasp Newton's law, which expresses a relationship between net force and acceleration, if you don't have an existing understanding of acceleration and of balanced forces. And secondly, having a faulty model will limit how well students will be able to reason in new situations. So it's important that we make explicit students' ideas and try to challenge them early on if we want students to develop a big idea understanding. That's why we need to follow the doctor's approach. Before prescribing an intervention, a doctor carefully assesses the patient. In the classroom, this means finding out whether the students have a good understanding of any essential prior concepts before teaching a new one. In other words, diagnose, then teach.